Afternoon, kids.
Afternoon, sir.
How are you today?
We are fine, thanks. How are you, sir?
I feel well. Kids, have you ever wondered why is it that when you turn on the switch on a wall, the light turns on? The topic for today is, what is electricity? We'll try to answer that question today. I brought with me my ancient breadboard that was made in the 1950s. Let's see. Okay, kids, now let's assume this switch is the one on the wall. The battery is the supply. Look what happens when I turn on the switch. Then the light turns on. Now the question still stands. What causes the light to turn on? Let us explore electricity. To be able to answer this question, we will need to take a tour to the physics world, where we'll look at the copper wire in the form of an atom, because basically we're working with copper wires. The copper wire have an atom like this. This is the nucleus. This is the first shell, second shell, third shell, and the fourth shell. The nucleus is formed by protons and neutrons. Protons are positively charged. Neutrons, they are neutral. They are not either positive nor negative. And then on the first orbit or first shell, we have 2 electrons. On the second one, we have 8 electrons, but I'm not going to draw all of them. On the third one, we have 18 electrons. And on a valency shell, which is the last one, we have only 1 electrons, which orbit very fast, and it's a little weaker than the rest. Since now we know the copper atom, I'll just draw a circuit in the form of atoms. I'm not going to draw the entire thing now. This is the nucleus at the center, and this is the valency shell. Yeah, I have a battery. This is how my circuit will look like. Oh, I missed the bulb now. Now this will be a bulb. This is the positive terminal, and this is my negative terminal. So what happened is, once you put the bulb in here, I didn't put the switch on purpose. Once you put a battery in here, then you close the switch, the positive terminal of the battery will attract this electron since it is negatively charged. Opposite charges attract each other. So the positive terminal will attract this electron. Now let's draw like this to show that it's gone. Now we'll remain with a hole here. Now since there's a hole here, this atom, the valency shell, which is the outermost shell of the atom, is now more like it's positively charged as well. So it will attract this electron. Now this is what will happen. Now this electron will leave this atom and flow to this atom. Now there will be a hole here as well, leaving this atom more positively charged. That will cause this atom to attract the electron from this atom. The same will happen here, the same will happen here, the same will happen here, and the same will happen here as well. Here. And when the electron gets to this point, when it moves now from this atom to this atom through the resistor in here, will cause the bulb to glow. That's what causes the bulb to glow when you turn on the switch on the wall. So basically, I can say electricity is the flow of electrons. So in our class, we won't be talking about electron flow. Rather, we'll be talking about a conventional current. Conventional current is the type of current that flows from positive to negative. And then the electron flows from the negative terminal of the battery to positive. So this is the electron flow. This side you have a conventional current. There you have it. So basically, current is the flow of electron. Now, as the electron flows in this direction, the hole looks like it's flowing in this direction. It's like it's flowing in the opposite direction to the electron, if you look at it that way. So that is why we say you also have a conventional current, in case that is confusing. It's just the flow of holes. Normally they call it holes. The electron flow is the flow of electrons. Now, the question is, if I can carry a copper wire like this, will it shock me? The answer is no, because I'm holding it right now, but it doesn't shock me. How come it doesn't shock me, but it have electrons? These electrons in a copper wire, they are standing still. They are not moving. They need a battery to energize the electron inside. Like here at the beginning, as soon as you turn the switch on, this battery attracts this electron and this electron and this electron, and then it starts flowing. That is why it is not advisable to carry a naked copper wire during the thunderstorm or the rain, because the electromagnetic field from the lightning, if it strikes, it will energize the electrons in that copper wire, and therefore you might get shocked and injured. I hope that makes sense. Now let's assume this battery of mine is a 1.5 volt battery. What does this 1.5 voltage means? Voltage basically is that push that causes the electron to flow either faster or slow. It's basically a pressure. The higher the voltage, the higher the push, or the more they push. So the more the electrons pass the setting point at a given time, the higher the current. Now, with all that being said, we now know what is electricity, which is the flow of electrons. For the electrons to flow, we will need a push or an energizer, which is the battery. Okay, actually, which is the voltage from the battery. The higher the voltage, the more the push. That voltage pushes electrons to pass through a certain point at a given time. The more the electrons that pass a certain point at a given time, the higher the current we have. But now these electrons, they don't just flow freely in a circuit. There is something that stops them or that blocks them from flowing freely, which is called a resistor. On the next class, we'll focus on a resistor. Since now we know what is voltage, what is current, next time we'll talk about a resistor. Peace.